Good morning, everyone. I am pleased to welcome you all today. Today, we will be discussing troubleshooting in HPLC analysis and remedial actions. This is a crucial topic for ensuring accurate and reliable analytical results. Over the course of this presentation, I will walk you through common issues encountered during HPLC analysis and how to effectively address them. So, let's get started and explore how to troubleshoot and resolve challenges in HPLC together. Let's begin by exploring what high-performance liquid chromatography, or HPLC, actually is. It's an advanced analytical technique that allows us to separate, identify, and quantify the components within a mixture. The core idea behind HPLC is based on the principle of differential partitioning. Essentially, this means that different compounds in a sample interact differently with two phases: the mobile phase, which is a liquid solvent, and the stationary phase, which is a solid adsorbent packed inside a column. In practice, we inject a liquid sample into a high-pressure stream of mobile phase. This stream carries the sample through the column, where the magic happens. Because each compound interacts differently with the stationary phase, they don't all travel at the same speed. This causes them to elute or come out of the column at different times. These are called retention times. Once separated, these compounds are detected using various detectors, such as UV, PDA, or fluorescence detectors. The signals from these detectors are then translated into a chromatogram, which visually represents the separation. HPLC is incredibly versatile and widely used across many fields: pharmaceutical analysis, environmental monitoring, food quality testing, and clinical research. Its popularity stems from its high resolution and sensitivity, meaning it can distinguish very similar compounds with precision. It also offers high accuracy and reproducibility, ensuring consistent results. Plus, it can handle complex mixtures that other techniques might struggle with. Overall, HPLC has become a crucial tool in modern analytical chemistry. It helps ensure product quality, safety, and regulatory compliance, making it indispensable in many industries. Let's take a closer look at some common issues you might encounter with HPLC. One of the first problems is no peaks or a very low response, which can indicate problems with sample injection or detector issues. Then there's peak tailing or fronting, which often points to column overload or contamination. Baseline noise or drift can be caused by temperature fluctuations or detector instability. High back pressure may suggest blocked or clogged columns, leading to increased wear or damage. Retention time shifts can be a sign of changing system conditions or mobile phase inconsistencies. Ghost peaks are unexpected signals that can interfere with your analysis, often resulting from contamination or carryover. This is where troubleshooting becomes crucial. Addressing these issues is key to ensuring your data is accurate and reproducible. It also helps minimize downtime, saving you time and costs in the long run. Maintaining proper system performance is essential, not just for reliable results, but also to prevent damage to your columns and instruments. Ultimately, good troubleshooting keeps your HPLC system running smoothly, ensuring high-quality data and prolonging the lifespan of your equipment. Now, let's talk about what to do when we encounter a problem where there are no peaks in our chromatogram. This is often referred to as Problem 1, no peaks. The first step is to consider the possible causes. One common reason might be that no sample was actually injected into the system. It's easy to overlook, but it's important to double-check that the injection was made properly. Another potential issue could be that the detector isn't set correctly. For example, if the wavelength isn't adjusted to match your analyte, you might end up not seeing any peaks at all. Additionally, the pump may not be delivering the mobile phase as it should. If the pump isn't functioning properly or there are leaks, the mobile phase won't reach the column, and you won't see any peaks. Finally, it's worth verifying that the column is properly connected. A disconnected or loose column can prevent the sample from passing through effectively, resulting in no peaks. Now for remedial actions. First, check the injector and the sample loop to make sure the sample was injected properly and is in place. Then, Verify the detector wavelength to ensure it matches the analyte you're analyzing. Next, inspect the pump flow and look for any leaks or irregularities that could disrupt mobile phase delivery. Lastly, ensure that the column is correctly connected and secured. By systematically going through these steps, you can identify and resolve the root cause of why you're not seeing any peaks in your chromatogram. Let's take a closer look at the second common problem, low peak response. This issue can stem from a few different causes. First, low sample concentration is often a culprit, meaning there simply isn't enough of the analyte in the sample to produce a strong signal. Second, detector sensitivity might be set too low, which can prevent us from detecting the full response. And third, sample degradation can occur, where the sample breaks down before analysis, leading to weaker peaks. To address these causes, we can increase the injection volume, which introduces more sample onto the column and can boost the response. Adjusting the detector settings, such as increasing sensitivity, can also help us capture a stronger signal. Lastly, preparing a fresh sample ensures we're analyzing intact, reliable material, which is essential for accurate results. By understanding these causes and applying these solutions, we can improve our peak response and ensure more reliable, consistent data. Let's talk about problem 3, which is peak tailing. This issue can really affect the quality of our results. One common cause is column contamination, which happens when impurities build up and interfere with the separation. Another cause is strong interactions with the stationary phase, where analytes stick too tightly, causing the tailing effect. Additionally, dead volume in the system can contribute, as excess space can lead to peak distortion and poor resolution. Now, for solutions. First, it's essential to clean or replace the column regularly to prevent buildup and contamination. Optimizing the mobile phase pH can reduce unwanted interactions, helping the peaks to appear more symmetrical. Lastly, reducing the dead volume in the system, like using better fitting connections or more efficient plumbing, can minimize peak tailing. Connecting this to our overall theme, addressing peak tailing is crucial for getting accurate, reliable chromatographic data. By understanding these causes and applying these solutions, we can significantly improve our analysis quality. Let's talk about problem 4, which is peak fronting. This issue often shows up when we see peaks that front or shift in the chromatogram. The main causes behind this are usually column overload, meaning we're injecting too much sample at once, or the sample itself being too concentrated. When the sample is overly concentrated, it can cause the fronting peak because the column gets overwhelmed. To address this, we can reduce the injection volume, essentially injecting less sample to prevent overload. Alternatively, diluting the sample makes it less concentrated, which helps achieve a more symmetrical peak. These solutions are important because they help us improve the accuracy and reliability of our results, keeping our chromatography running smoothly and our data trustworthy. Let's talk about problem 5, which is baseline noise. This is a common issue in chromatography, and understanding its causes is key to minimizing it. One cause is air bubbles in the detector, which can create fluctuations in the baseline signal. Mobile phase impurities are another culprit. They can introduce unwanted noise and affect the accuracy of your results. Additionally, detector instability itself can lead to inconsistent readings over time. Now, how do we address these issues? First, degassing the mobile phase is essential. Removing dissolved gases helps prevent bubbles from forming. Second, using high-purity solvents reduces impurities that could cause noise. And finally, stabilizing the detector, whether through proper warm-up procedures or regular maintenance, ensures it operates smoothly and provides reliable data. By focusing on these solutions, we can significantly improve the baseline stability and enhance the overall quality of our chromatography results. Let's talk about problem 6, which is baseline drift. This is a common issue in chromatography, and understanding its causes is key to managing it effectively. One major cause is temperature fluctuations. When the temperature isn't stable, it can lead to changes in the detector response, causing the baseline to shift. Another cause is changes in the mobile phase composition. Variations here can also impact the baseline, making it appear unstable or drifting over time. Now, to address these problems, there are a few practical solutions. First, maintaining a constant temperature is crucial. Using a column oven or temperature-controlled environment can help keep things steady. Second, always prepare fresh mobile phase. Old or improperly stored mobile phase can cause inconsistencies. And third, ensure proper mixing of the mobile phase. This ensures uniformity and prevents composition fluctuations that can lead to baseline drift. By focusing on these solutions, we can significantly improve our baseline stability, making our results more reliable and accurate. This ties into the overall goal of achieving robust and reproducible chromatography results. Now, let's move on to problem 7, which is high back pressure. This issue can often be traced back to a couple of common causes. One of the main culprits is a blocked column or frit, which can restrict the flow and increase pressure. Another cause to consider is particulate matter in the mobile phase, which can also clog the system and contribute to high back pressure. To resolve this, the first step is to replace or clean the column thoroughly. Regular maintenance can prevent buildup and keep everything flowing smoothly. Additionally, filtering the mobile phase with a 0.45 microM or 0.22 microM filter is crucial to remove any particulates before they enter the system. Finally, it's important to check all tubing for any blockages or kinks that could impede flow. By addressing these issues proactively, we can maintain optimal system performance and avoid unnecessary downtime. Remember, high back pressure isn't just a nuisance. It can impact data quality and instrument longevity if left unchecked. Let's talk about problem 8, which is retention time shift. This is a common issue that can affect our analysis accuracy. The main causes include flow rate variation, which means if the pump isn't delivering a consistent flow, the retention times can shift unexpectedly. Changes in the mobile phase composition also play a big role, since even small variations can impact how compounds move through the column. Lastly, column aging is a factor. Over time, columns can degrade, leading to changes in retention times. Now, to address these issues, we have some practical solutions. First, calibrate the pump regularly to ensure it's delivering a consistent flow rate. Second, prepare our mobile phase carefully and consistently to avoid any composition variations. And if the column has been used extensively and shows signs of wear, replacing it can restore reliable retention times. By focusing on these points, we can maintain more stable retention times, which is crucial for accurate and reproducible results across our analyses. Now, let's talk about problem 9, which is ghost peaks. These are a common issue in chromatography, and understanding their causes is key to preventing them. One major cause is contamination from previous runs. If residues are left in the system, they can show up as false peaks in your current analysis. Another cause is impurities in the solvents we use. Even small amounts of impurities can lead to ghost peaks that interfere with your results. To address these issues, there are some practical solutions. First, always flush the system thoroughly between runs to remove any residual contaminants. Using fresh solvents each time is also crucial, as it minimizes the risk of introducing impurities. Lastly, don't forget to clean the injector regularly. A clean injector ensures that no leftover residues cause ghost peaks, helping maintain the integrity of your analysis. By following these steps, we can effectively reduce ghost peaks and improve the accuracy and reliability of our results, which ties back to our overall goal of achieving high-quality, reproducible data. Let's now focus on some essential preventive maintenance tips that can really help optimize our system's performance. First, regular system flushing is crucial. It helps remove any accumulated debris or contaminants, ensuring the system runs smoothly and prolongs its lifespan. Next, always remember to filter and degas the mobile phase. This step is vital because it prevents bubbles and particulates from interfering with our analysis, maintaining accuracy and reproducibility. Using guard columns is another key point. They act as a protective barrier, trapping impurities before they reach the main column, which ultimately extends the life of our analytical columns. Maintaining consistent operating conditions is also essential. Fluctuations in temperature, pressure, or flow rates can impact our results, so stability is key. Lastly, routine calibration and validation are fundamental practices. They ensure our instruments are accurate and reliable over time, giving us confidence in our data. When we incorporate these preventive measures into our routine, we not only safeguard our equipment, but also uphold the integrity of our analytical results, which is at the heart of our overall quality assurance. In conclusion, troubleshooting really is a cornerstone for ensuring reliable HPLC results. When we take the time to identify and address issues as they arise, we can maintain the accuracy and consistency of our data. Understanding the root causes behind problems not only helps us fix them faster, but it also improves our overall efficiency by preventing recurring issues. Preventive maintenance plays a crucial role here, as it significantly reduces the likelihood of system failures and downtime. And finally, proper training is key. When everyone involved understands the system well, we see better analytical performance and more dependable results. All these points tie together to emphasize that a proactive, knowledgeable approach is essential for optimal HPLC operation and data quality. For further support, please feel free to contact us. We're here to help you with any questions or additional information you might need. Thank you so much for your time and attention today. We appreciate your engagement and look forward to assisting you in any way we can.